Good morning, student. Today we are going to discuss regarding the generation of the rotating magnetic field. Generation of the rotating magnetic field. Generation of the rotating magnetic field. Simply you are calling RMF, rotating magnetic field. So, what is the rotating magnetic field? How to produce this rotating magnetic field? Now, what are the applications of this rotating magnetic field? We will see in this class. So, first of all, what is the RMF, rotating magnetic field? A rotating magnetic field is a magnetic field that rotates in a space with the constant magnitude and constant speeds. So once again, I will repeat this definition. A rotating magnetic field is a magnetic field that rotates in a space with the constant magnitude and constant speeds. So first of all, we have to produce the flux. After that, the flux has to be rotate. Has to be rotate. First of all, what is the condition to produce the flux? Whenever current is flowing the conductor, flux will be produced. Whenever current is flowing through the conductor, flux will be produced. Just that is the production of the magnetic field, or just generation of the magnetic field. Now this is the rotating magnetic fields. Now rotating magnetic field. How to produce this rotating magnetic field? So here important thing is to rotate the flux, two things are required. One is the space, one is the pace. One is the space, one is the pace. Suppose take the two coils. Take the coils, two coils, coil 1 and coil 2. This is the coil 1, this is the coil 2. These two coils are spaced. This is the coil 1, this is the coil 2. Coil 1, coil 2. Now coil 1 is placed on the x-axis, coil 2 is placed on y-axis. Now space between these two coils is the 90 degrees is required. 90 degrees is the required. That is the pace. So in the first coil flowing current is I1, in the second coil flowing current is the I2. In the first coil flowing current is I1, second coil is the I2. Whenever current is flowing the conductor or coil, flux will be produced. Here producing flux is the phi1. In the second coil producing flux is the phi2. In the first coil I1 current is flowing, this I1 current produces the phi1 flux. In the second coil phi2 flux is phi2 current is I2 current is flowing, producing flux is the phi2. So here total flux is the phi t is equal to, total flux is equal vector sum of phi 1 bar plus phi 2 bar. The total flux, this total flux is called the rotating magnetic field. Rotating magnetic field. Now this total flux is rotating with constant magnitude and constant speed. So this is called the rotating magnetic field. Rotating magnetic field. Generally, we are not using two-phase systems. All of the single phase or three-phase systems. Single phase or three-phase systems. So we are discussing regarding the three-phase systems. Three-phase system, how rotating magnetic field is producing. So three-phase system. Take the three coils. Take the three coils. This is the R coil, Y coil. This is the B coils. R, Y, B. These three are placed by 120 degrees apart. R phase and Y phase 120 degrees is required. Is the 120 also 120. So space between these two coils are 120. R2Y is the 120, Y2B is the 120, B2R is the 120. This is the place difference between these three coils. So for this three phase system, if you give the three phase balanced supply, three phase balanced supply, three phase balanced supply, then in the R coil flowing current is the IR, in the Y coil flowing current is the IY, in the B coil flowing current is the IB. In the R coil flowing current IR, in the Y coil flowing current IY, in the B coil flowing current the IB. So whenever current is flowing in the coil, circuit conductors flux will be produced. This IR current will produce the phi R flux in the R coil. In the same way, this IY current will produce the phi Y flux in the Y coil. In the same way, IB current will produce the phi B flux in the B coil. So here three fluxes are producing. One is the pi R, pi Y, pi B. Pi R, pi Y, pi B. So now total flux is the pi T is equal to total flux pi T is equal to vector sum of pi R bar plus pi Y bar plus pi B bar. So these are the individual flux pi R, pi Y, pi B. Pi R, pi Y, pi B is the individual flux. Now total flux is the vector sum of these three fluxes. Pi T is the total flux equal pi R, pi Y, pi B. So this total flux is the rotating magnetic field. Rotating magnetic field. This is the rotating magnetic field. This rotating magnetic field will rotate with the constant amplitude, constant magnitude and constant speed. Constant speed. Constant magnitude and constant speed. This is the rotating magnetic field. This is the rotating magnetic field. So we'll see these three phases mathematical equations and three phases waveforms and three phase vectors. One by one we'll discuss now. So take the three phases fluxes, three phase fluxes pi R and pi Y and pi B. Now we will take the instantaneous values of the fluxes. Instantaneous values of the fluxes pi R, pi Y, pi B. So pi R flux is called mathematical equations of the flux. Equations pi R is equal to, as per the instantaneous voltage formula, V is equal to Vm sin omega t. In the same way, pi R is equal to flux also maximum flux into sin omega t. Sin omega t. Pi Y is equal pi m sin omega t minus 120. So angle between pi R and pi is the 120. Pi R and pi is the 120 degrees. 120 degrees. So pi R, pi m sin omega t is the reference flux, reference value. This is the after 120 degrees pi Y will be starts in the same way. Pi B is equal pi m sin omega t minus 240, or we can write this value pi m sin omega t plus 120. We can write omega t minus 240 or omega t plus 120. So these three are the mathematical representations, mathematical equations. Now compare the waveforms of these three waveforms. So omega t, now we are taking the flux phi on the y axis, we are taking the flux, x axis we are taking the angular frequency omega t. So first we will draw the pi r flux. Pi r flux that is starting at the reference, starting from the zero, starting from the zero, starting from the zero. After 120, pi y flux will be starts. After 120 degrees, it may be nearly will come here. If you extend like this, it will come like this. Now pi b flux after 240 means it will starts. So this is the pi r, pi y is the pi b fluxes. Pi r flux, pi y and pi b. They are the three phase fluxes waveforms. So is the 0. This is the maximum flux, the positive value. This is the maximum flux of the negative value. These are the negative, these are the positive. These are flux waveforms. R phase flux, Y phase flux, B phase flux. This is the highest point is the peak value or maximum value. Also peak value or maximum value. So we will calculate the what is the total flux. What is the total flux? This total flux is nothing but the our required rotating magnetic field. So phi t is equal to vector sum of phi r bar plus phi y bar plus phi b bar. This is the total flux. This total flux is the rotating magnetic field. This total flux will rotate with the constant magnitude and constant speeds. So we will derive the what is the total flux magnitude in this from these equations. So take the case 1. Take the case 1. At omega t is equal 0 instant. Omega t is equal 0 degrees. 0 degrees. At omega t is equal 0 instant. In this instance, better to take the 0 cross points. This is the 0, 0, 0 points. Then one flux will be 0. Remaining two flux are available. That is easy to calculate the total resultant flux. Then easy to calculate the total flux. So take the omega t is equal to 0. Omega t is equal to 0. Already you have seen pi r is equal to pi r is equal to pi m sin omega t, pi y is equal to pi m sin omega t minus 120, pi b is equal to pi m sin omega t minus 240 or pi m sin omega t plus 120 degrees. So substitute the omega t is equal to 0 in the three equations. Substitute the omega t 0 at three equations. Suppose substitute the in the first equation pi r is equal to omega t sin 0 is the 0. So sin 0, this value is omega t is equal to 0 means total sin 0 is the 0. Pi r is 0. Pi r is 0. So pi y is equal to substitute the omega t equal to 0. This is the 0. Pi m sin minus 120. So from this value we will get minus pi m sin 120. Bring this minus here, minus pi m sin sin 120. We can write sin 90 plus 30. So from this, if you substitute the omega t is 0 here, we will get the pi y is equal to minus root 3 by 2 into pi m, minus root 3 by 2 into pi m. In the same way, pi b is equal to we will get the plus root 3 by 2 into pi m. Substitute the omega t is equal to 0 in this equations. This is the positive value, this is the negative value, this is the 0 value. So pi r is equal to 0, pi y is equal to minus root 3 by 2 pi m, pi b is equal to plus root 3 by 2 into pi m. This is the flux values, the flux value. So total flux is equal to pi t is equal to total flux is equal to pi r bar plus pi y bar plus pi b bar. So total flux vector sum pi t is equal to pi r is the 0. Pi r is the 0. So pi y is equal to minus root 3 by 2 minus root 3 by 2 pi m bar plus root 3 by 2 into pi m is the vectors. This is the total flux is equal to this is the 0. This is the minus root 3 by 2 pi m plus root 3 by 2 into pi m. So we have to add these two equations vectorially. Pi t is equal to minus root 3 by 2 pi m plus root 3 by 2 pi m. This is the value. So if you draw the vectors, pi r, pi y is the pi b, pi r, pi y, pi b. Pi r, pi y, pi b. If we see, pi r is the 0. Pi r is the 0. This is the 0 in this instance. 0. Pi y is equal to minus root 3 by 2 into pi r. Pi y is the negative value. Pi y is the negative. This is the positive value. Take the opposite direction, the negative value. This is the pi y value. The pi y value. So this is the pi b is the positive value. Pi b is the positive value. The pi b is the positive value. Pi b is the positive, pi y is the negative value. Now this is the minus pi m. Minus pi m. So total flux is the vector sum of pi y and pi b. Total flux is the vector sum of pi y and pi b. Vector sum of these two values. So take the vector sum here. This is the vector sum. This is the pi t. Total flux is the vector sum of pi y, vector sum of the pi y and pi b. So here angle is the 120. This is the 60 degrees. This is the 60 degrees. Now we have to calculate the pi t value. Pi t value. Total flux is required. So pi t is equal to, take the parallelogram principles, square root of what is the pi b value? If you see the pi b value plus root 3 by 2 into pi m. Pi y value is the minus root 3 by 2 into pi m. So plus root 3 by 2 pi m whole square plus minus root 3 by 2 pi m whole square minus 2 root 3 by 2 pi m. Here minus become plus root 3 by 2 pi m. What is the angle here? Cos 60 degrees. Cos 60 degrees. So substitute the values pi y value, pi b value in the uh, equation. We will get pi t is equal to, after solving this total equation, we will get the 3 by 2 into pi m. Or I can write pi t total flux is equal to 1.5 times of the pi. This is the rotating magnetic field magnitude value. Magnitude value, its amplitude is the 1.5 times or 3 by 2 times of the maximum flux. This is the amplitude or magnitude. Magnitude of the rotating magnetic field is the rotating magnetic field magnitude is the 1.5 times of the maximum flux. The maximum flux. So at case 1, at case 1, at omega t is equal to 0, now flux magnitude is the 1.5 times of the maximum flux, and instant is the, at this instant is the first instant 1. This is the at omega t, at total flux instant is the this one, at one instant is the this one. So take the case 2. Case 2. Case 2, take the omega t is equal 60 degrees. 60 degrees. Omega t is equal 60 degrees. So omega t is equal to 60 degrees. Substitute in the first equation. Already you have seen in the equations. In the omega t 60 degrees, substitute in the first equation, second equation, and third equations. Substitute the omega t is equal to 60. Pi r is equal to pi m sin 60. Sin 60 means root 3 by 2. In the same way, substitute the 60. 60 minus 120. In the same way, substitute the pi m sin 60 plus 120. Substitute the omega t is equal to 60 degrees in the these three equations. These three equations. Then we will get pi r is equal to plus root 3 by 2 into pi m. Pi y is equal to minus root 3 by 2 into pi m. Pi b is equal to 0. Pi b is equal to 0. So total flux pi t is equal to vector sum of pi r bar plus pi y bar plus pi b bar. So pi t is equal to, what is the pi r bar plus root 3 by 2 plus root 3 by 2 pi m. Pi y is the minus root 3 by 2 into pi m plus pi b is the 0. Pi b is the 0. So draw the again phasor diagrams. This is the pi r is the, in this case pi r is the plus root 3 by 2 into pi m, and pi y is the minus root 3 by 2 Pi y is the minus root 3 by 2. Pi y is the minus root 3 by 2. Pi m. Pi m. Pi b is the 0. Pi b is the 0. So again pi b, this is the 0. This is the pi b is the 0. So take the pi r and pi y. Pi r and pi y. Now vector sum of these two. So it will give the this is the pi t. This is the pi t. So calculate the this value. The value. See, in the previous case, pi t is the total flux instant is the here. Is the flux position. First case. Now second case, first flux position is the now this one. Now flux is rotating from position 1 to position 2. Position 1 to position 2. So in first case, flux is the in this position. Now second case, case 2 at omega t equal to 0, flux is the in this position. In the second case, flux is the in this position. Now flux is going to change from this position to this position. This position to the this position. So flux is rotating from position 1 to position 2. Flux is rotating position 1 to position 2 like this. Now in the case 1, flux is the total flux is the position 1. Now flux is going to move, is going to rotate from position 1 to this is the position 2. So here also we have to calculate the total flux. The total flux. Substitute the pi r, pi y, pi b value. Substitute the pi r, pi y, pi b value. So pi t is equal to vector sum of take the same parallelogram principles plus root 3 by 2 into pi m whole square plus pi y is a minus root 3 by 2 into pi m whole square minus 2 root 3 by 2 pi m minus minus plus root 3 by 2 into pi m cos 60 degrees. Cos 60 degrees. After calculating total flux magnitude is the we will get the same 3 by 2 into pi m. Total flux is the 1.5 times of the pi m. This is the flux magnitude. Total flux rotating magnitude is the 1.5 times of the maximum flux. So here also magnitude is same. Here also magnitude is same. So in the position 1 also magnitude is the 1.5 times of the maximum flux. In the position 2 also magnitude is the 1.5 times of the maximum flux. But the position is going to change from first position to this is the position 1. This is the position 2. So go for the you will see one more case. Case 3. Case 3. Case 3 at omega t is equal 120 degrees. 120 degrees. This omega t 120 degrees substitute in the equations. Pi r, pi y, pi b. Substitute the omega t is equal to here the 120. Pi r is equal to pi m sin 120. Pi y is equal to pi m sin omega t minus 120. Pi b is equal to pi m sin 120 plus 120. So substitute here we will get the pi r is equal to pi r is equal to pi r is equal to plus root 3 by 2 into pi m. Pi y is equal to 0 here. Pi b is equal to minus root 3 by 2 into pi m. Minus root 3 by 2 into minus root 3 by 2 pi m. So pi t total flux is equal to pi r bar plus pi y bar plus pi b bar. So total flux pi t is equal, pi r is the plus root 3 by 2 into pi m, pi y is the 0 plus pi b is the minus root 3 by 2 into pi m. This is the total flux. So you have to calculate the total flux also. So go for the pi r is same positive value, pi r is the same, we will get the positive value, there is no change, pi r is the same positive value. Now pi y is the 0, pi y is the, this is the 0, this is the pi r is same positive value, pi y is the 0 here. Now pi b is the, pi b is the minus value. So pi b is the positive value, this is the negative value, minus pi b, minus pi b. So now take the vector sum of pi r and pi b. So take the vector sum of pi r and pi b. Now here angle is the 120, here is the angle is the 60 degrees, the 60 degrees. So now this is the position 3. Now position 3. Now position 1 flux is here. Position 2 flux is going to move from position 1 to position 2. Position 1 to position 2. Now position 3 flux is again going to move from position 2 to position 3. This is the position 3. Now position 3. So first of all, flux is the, in the first case flux is the in the position 1, in the second case position is the flux is the position 2. Now third case flux is again going to move second position to position 3. Now this is the position 3. Now this is the position 3. So this is the position 1, 2, this is the 3, this is the 3. Flux is going to change, move from position 1 to 2, 2 to 3. Now flux position is the at this point, at this point. So flux is going to rotate, flux is going to rotate from position 1 to 2, 2 to 3. So this is the flux position here, is the flux position. Now here also let us calculate the total resultant flux. Pi t is equal to, total flux is equal, take the same parallelogram principle, parallelogram principles is equal to pi r is the plus root 3 by 2 plus root 3 by 2 into pi m whole square plus 0. Actually this is the 0 value, this is not required, not required. Take the pi b minus root 3 by 2 into pi m whole square minus root 3 by 2 pi m, here minus minus will come plus root 3 by 2 into pi m is the cos 60, cos 60. So from here we get the pi t is equal 3 by 2 into pi m, or pi t total flux is the 1.5 times of the maximum flux. This is the flux magnitude, this is the flux magnitude. So magnitude is in all cases, in all cases, first case, second case and third case, it flux magnitude is same, flux amplitude is the same, 1.5 times of the maximum flux. So is the 1.5 times of the maximum flux. Is the amplitude is always case 1, case 2, case 3, go for case 4 also, in always they has to be maintain the constant flux, constant amplitude or constant flux. So this value is the 1.5 times of the maximum flux, 1.5 times of the maximum flux. This constant flux is going to is rotating in the space, rotating in the space. In the case 1, this constant, this flux is the position 1 in the position 1, in the second case position 2, in the third case position 3. So we will see one more case also, more case also. Case 4, case 4, case 4 also at omega t is equal 180 degree. Omega t is the 180 degrees. Now here pi r is 0. You substitute these values in the mathematical equations. Pi r, pi y, pi b, pi y is equal plus root 3 by 2 into pi m, pi b is equal to minus root 3 by 2 into pi m, minus root 3 by 2 into pi m. So total flux pi t is equal pi r bar plus pi y bar plus pi b bar. So pi t total flux is equal, so pi r value is the 0 plus pi y is the root 3 by 2 into pi m plus minus root 3 by 2 into pi m. This is the total flux. This is the total flux. Total flux. Here also let us calculate the total flux magnitude value. So if you draw the, go for the phasor diagrams, vectors at omega t is equal to 180 degrees, pi r is 0. Now this one is the 0. Now pi r is 0, pi y is equal to positive value, this is the positive value, pi b is equal to negative, pi b is the negative. Now already negative minus pi b is there, now minus pi b is there. So now vector sum of pi y and pi b, vector sum of pi y and pi b. Now this is the resultant vectors, this is the pi t total flux or resultant flux. So see here, in this case, case 4, flux is going to rotate from position 3 to position 4. Now this is the position 3, this is the position 4, position 4. So in the case 1, position 1 here, rotating magnetic field will starting from this point. So case 2 means angle is going to change from 0 to 60 degrees. Now this is the, now this is the case 2, this is the position 2 of the resultant flux, position 2 of the resultant flux. Now angle is going to change from omega t is equal to 60 to 120 degrees. Now this is the position 3, now position 3. Now this is the position 4. Flux is rotating from position 1 to 2, 2 to 3, 3 to 4, will rotating like this, in this directions, in this direction. Rotating magnetic field is rotating from position 1 to 2, 2 to 3, 3 to 4. If you go for one more angle, total 360 degrees will be rotated. Rotating magnetic field rotating the total 360 degrees in the given space. The given space. So this is the rotating magnetic field generation, and how to produce the this rotating magnetic field, how position is going to change after by changing the angle from 0 is equal omega t is equal to 0, position 1, omega t is equal to 60, position 2, omega t is equal to 120, position 3, omega t is equal to 180, position 4. If you change the angle again, this flux is moving from position 4 to position 5, and like this. So 120 total, this flux is rotating in the circularly rotating in the space. Now this is the rotating magnetic field concepts. So where we are using the rotating magnetic fields, what are the applications of the rotating magnetic field? This rotating magnetic field we are using in the induction motors. To start the induction motor, rotating magnetic field is required, and in the same way we are using this rotating magnetic field in the synchronous motors also, where self starting, where starting is required, where the to start the motors uh, we are using the rotating magnetic field. This is the concept of the rotating magnetic field. So next class we will see the construction and working principle of the three-phase induction motors, how this rotating magnetic field we are using in the three-phase induction motors. One by one we will discuss in the coming classes. Thank you.